Hello, my good student, and welcome. This is Dr. Sirme. For this video, I wish to take you through a full Form 3 paper. That is a Form 3 mathematics paper. And to start with, I wish to go through the questions first. So my students, sit back and go through the paper with me. That is a Form 3 mathematics revision paper. Good. That is the cover page. My student, I always tell you the instructions are very important. Yes, the instructions are always very important. That is it. Question 1 to 16, short structured questions that are very compulsory. Then question number 17 to 18, you're supposed to attempt 5. You do your best 5. Question 1 to question 4, you can see there. The first question, application of logarithm there. Question 2, that is quadratic expressions. Yeah, that is factorization. Question 3, binomial expansion. Question 4 is commercial arithmetics, especially depreciation. Question 5, yes, indices. That is a Form 2 work, yes. Then you have question 6, that is application of algebra. Question 7 is vectors. Question 8, as you can see, these are tangents and chords there and a circle. Question 9, that is quadratic equation, solving quadratic equation. Question 10, that is further logarithm. Question 11, that is area of a triangle, area of part of a circle. Question number 12, yes, that's about time. Question number 13, trigonometry. Question number 14, probability. Question number 15, that is equation of a straight line. Question number 16, that is approximation and error. Section 2, where the student is expected to do 5. But for this case, being a revision paper, I will do the 8 questions. Question number 17 is matrices and application of matrices to solve simultaneous equation. Question number 18 is application of quadratic equations. Question number 19, higher purchase. That means it is commercial arithmetics 2, the Form 3 commercial arithmetics. Question number 20, that is sequencing and series. 21 is vector. Good. 22 is formula and variations. These are variations, yes. Question number 23, this is statistics. Yes, statistics. Then question number 23 continues with a graph, a histogram there. Then question number 24 again is probability. So my student, that is the end of the questions. The end of the questions. What you can do, my student, is to stop the video and attempt the questions before I do the questions for you shortly. Thank you very much. Okay, this is question 1. Question 1, the student was supposed to apply logarithm to solve the question given here. Now, for my student, you should just know that the catch is here, that you cannot operate numbers, especially the subtraction, using logarithm. So the student was expected to first of all do the subtraction. Like I've done here, 23.67, you subtract 5.891. And by doing that, the student got that. Then remember, we are using 4-figure mathematical table. So we round off the number to 4 significant figures, and that's where the student gets the first B mark. Then of course now the student is to go ahead and multiply whatever is in bracket here. Yes, the answer I've obtained here, then I multiply by the number outside there. The logarithm of this number written in standard form as it is, the logarithm of my new number here, this one, yep, I write it down. Yes, my student, I just write it down. Then I'm multiplying, so I add the logarithm. I add the logarithm by adding, I get this. So by getting the two logarithm, method 1, then there is another operation here, square root. Square root, you divide the logarithm, the sum of the logarithm by 2, or you multiply by a half. By doing that, the student got that. Then the student goes ahead to find the anti-logarithm of this number, and this is the anti-logarithm. You write it, you get the answer. Actually, that question should go with 4 marks, and that is number 1. Number 2, the student was expected to simplify. Yes, the student was simply supposed to simplify the whole of this expression given here. Looking at the upper one, what we are calling the numerator here, this is a difference of 2 squares. By that I mean 4x squared has a perfect square root. The y squared has a perfect square root. So it will look something like this. Yeah, something like this. This is called a difference of 2 squares. So this is the expanded form. We can factorize. By doing that, or rather by factorizing, it means this will end up being a plus b multiplied by a minus b. And that is all I've done here. That I get the square root here, 2x. I get the square root here, minus y. So 2x minus y multiplied by 2x plus y. And that's where the student gets the first mark. That's where the student gets the first mark. Factorizing the upper expression. Then we consider the lower expressions here. The lower expression is just a quadratic expression. So we only need to factorize it. Yes, my student. So what I need to do, I take 3 multiplied by 2. So that is 6. So that is 6y squared x squared. You know, and of course the second term here is negative 7. So I'm looking for 2 numbers such that their product is 6 and their sum is negative 7. So my student, one thing you should consider, or you should remember, that if the product is a positive, it means both numbers are positive or they're both negative. And the vice versa. If, for example, the product is negative, it means one of the number is negative. So like for this case, the 2 numbers must be negative, considering that their sum is negative 7. So the 2 numbers must be negative. And therefore the 2 numbers are negative 6 and negative 1. I multiply them, I get positive 6. I add them, I get negative 7. And that is all I use to express the lower term, actually the lower expression here. And by doing that, the second term, I expand it like this. Instead of writing negative 7, I write negative 6, negative 1. Then I group them. I group this and this 1. Then I do factorization. Whatever is common, 3y outside. Then what remains, y minus 2x. What is common here, x is common. So you factor it out. So then what remains, this. My student, this one should be the same as this for easy factorization, if at all it's a normal and ordinary factorization. Then after doing that, I end up with this. So I can factorize this out, y minus 2x out. Then what remains, 3y minus x here. So that's where the student gets the other mark. Now, what exactly do I need to do? The factors for the upper expression over the factors for the lower expressions. Ordinarily, if I look at them directly, there should be at least a term that is the same, and then I cancel. But looking at it, the terms looks different. The only term that looks almost, it is that, but they are not. My student, if you consider this 2x minus y, y minus 2x, they are not the same. But the way to make them the same, yeah, or they look alike, you can factor out a negative 1, like I've done here. Look at this. I have factored out a negative 1. My student, look at this. A minus b, this one, it's the same as negative 1 of b minus a. If you look at this, these are just but the same thing. If I open the bracket, the b will be negative, the a will be positive, just like it is here. So that's what I've done. And by factoring out a negative 1, whatever was y minus 2x becomes 2x minus y. And now they are the same. I can cancel this and this one. Then what remains? 2x plus y, 2x plus y. Then I can multiply the whole term again by negative 1. If I do that, the x that was negative will be positive. Then the y that was positive initially will be negative. And that's where the student gets the final mark. I know this step here, it's very tricky, but my student, you should know it. That is question number 2. Question number 3 is on binomial expansion. Yes, binomial expansion. 1 minus a half x raised to power 6. Yes, raised to power 6. Now, all that the student need to know, it's the binomial coefficients. These are given at the back of your mathematical table. You can generate them. Yes, you can generate them from your calculator. If you consider your calculator, there is a key that looks like this. Yes, and combination R somewhere. Just look for it. For example, if I need the first coefficient, this one, for power 6, it will simply be 6 combination 0. I'll get 1. The next one will be 6 combination 1. The next one here will be 6 combination 2. 6 combination 3, like that. I can simply, in case you do not have your mathematical table, or you do not have, you do have the calculator. That's how you can work it out. Or rather, you can generate that triangle. It is called the Pascal's triangle. 1, then 1, 1, then you add up 1 plus 1, 2, then 1, 1 plus 2, 3, then 2 plus 1, like that. You generate that. Otherwise, that is not a big issue there. So these are the coefficients. Also, I need to attach the coefficients there. Yes, I'm told to go up to the 4th term. So not a must, I do the whole of it. Then the first term here, I start with it with the highest power. So it is 1 to power 6. The next term here, negative a half x to the power 0. So what exactly happens? The first power or power that I've used here will keep on decreasing, and this one will increase. Just that simple expansion. So the first term here, the power start with the highest, it will keep on decreasing. The other term here, that is negative a half x, the power starts from 0, goes on increasing up to the maximum of 6. Good. So the coefficient is here. So the first 1 raised to power 5, then negative a half x raised to power 1. Of course, the sum must add up to 6. Then I have my coefficient 15, the third one, 1 raised to power 4, then negative a half x raised to power 2, plus 20, the next coefficient, yes, 1 raised to power 3, negative a half x raised to power 3, okay, plus the story continues. But for this one, I'm going up to the 4th term. So the whole of this, it will reduce to 1. The whole of this, remember there is a negative here, so the whole of this now will be negative, okay? And by this, already the student has a mark. The negative now makes this positive. So 6 divided by 2, 3. X is raised to power 1. We go on. Now we are talking about a half, negative a half times negative a half. You get 1 over 4. 1 over 4 multiplied by 15, which is 15 over 4. X squared. Yes, x squared. Again, now here you'll be doing a negative a half raised to power 3. That would be negative 1 over 8. So it will be 20 over 8. And there's a negative because of this. So if you simplify, that is 5 over 2. X is raised to power 3. And with that, the student has the expanded form there. Not very complex, my student there. Now, the student is expected to use the expanded form, yes, this one, to solve 0.98 is raised to power 6. So what is the student expected to do? Equate this to what was in bracket there. And that is all I've done here. That 1 minus a half x is equal to 0.98. Then I go ahead to solve for x. And by doing that, I have it. I only need to take the x here. My x, yes, my x is here, my x, and I substitute it where there is x. And that's what I've done. I have substituted it very carefully. This one is raised power 1, this is raised power 2, this is raised power 3. If I key in with my calculator, I will end up with the answer there. And even if I key in these figures raised power 6, the answer will be approximately the same. Otherwise, that is number 3. And here comes number 4. This question is a question on depreciation. Depreciation, how some items can lose value. And you're told that there is an item that had a value of 800,000. And then after 4 years, after 4 years, the value of this commodity dropped to 550,000. So the question is, you work out the rate of depreciation per year. So with that, the formula is given here. Amount after the period of time is equal to principal multiplied by 100 minus r over 100, everything raised to power n. Remember, you can just write it equals to p into 1 minus r over 100 raised to power n. It is the same. Now, all I need to do is to substitute the values like I've done. So this is the amount, this is the p, yes, the n is there. After doing that, I can divide both sides. Yes, I divide both sides by 800,000. Even on this side, I divide by 800,000. Yes. And by doing that, if the student is able to substitute the original one, the student has a method 1. By doing this, the student goes ahead to get 0.6875. On the other side, it is 100 minus r over 100. Now, I want to remove the power 4. So the fourth root on both sides. Fourth root here, and the student is able to get the second mark. All that the student needs to do now is to equate the fourth root here. Yes, the fourth root, I've worked it out for you, equals this. You cross multiply. If you cross multiply this one, you get 91.058. Then, of course, if you multiply this by 1, you get this. All I'm trying to do here is to just work out the value of r. R, you bring it on this side, it will be positive. This one will be 100 minus 91, and finally you get that is the rate, 8.94% per year. So that is the rate at which the commodity is depreciating. Number 4 done. This is number 5. Number 5, the student was expected to solve that question. That is a question on indices. And with that, you have 8 to power x plus 2 there and 128. And this is 2. So what we need to do, my student, is to express 8 and 128 with a base of 2. Yes, with a base of 2. Because this one is already to the base of 2. So what I do with this 8, it is 2 to power 3. And originally it had x plus 2 as the power. So if I do for 128, like I've tried to do here, 128 is 2 to power 7. So if a student is able to do that, a mark. Then the student is now to use the powers. Over here we are multiplying, so we add the power. So x minus 3 plus 3x plus 6 now equals to 7. Yes, equals to 7. Actually that is where the student scores the first mark. Aye. Then, if a student goes ahead to solve for for x in this case, get 1. That is a simple solution like I've just done for you student here. Thank you. That's number 5. This is question number 6. And question number 6 here is application of algebra. So how does the question state? The question states clearly that 5 years ago, the age of the mother was 4 times the age of her daughter. In 4 years' time, the age of the mother will be 2.5 times the age of the daughter. Now, what exactly should you do? Like for my case, I have used x to represent the current age of the daughter. So x. So 5 years ago, the daughter was x minus 5. Okay, that is very simple and easy to reason. And the statement is very clear that the age of the mother was 4 times the age of the daughter. So if the daughter is x minus 5, Therefore, the mother will be 4 times. That is 4 multiplied by x minus 5. That is the age of the mother 5 years ago. In 4 years' time, the daughter will be x plus 4. The mother will be the age of the daughter multiplied by 2.5. Just that. So all we're looking for is the present age. Yeah, the present age of the mother. I can decide to do, it is her age 5 years ago. I add 5. So it is 4x minus 20, then plus 5. Now, how do I go about this? I can start with this part. That 4x minus 20 plus 9. Why are we adding 9? Because I want to use the age of the mother 5 years ago to get her age in 4 years' time. So plus 9. This age, remember that is the age of the mother. Yes, the age of the mother 4 years to come. Her age 5 years ago plus 9. Because they are 5 years back, 4 years ahead there. Is equal to, okay, the age of the daughter multiplied by 2.5. That's all I've done here. 2.5 multiplied by x, it is 2.5x. 2.5 times 4, it is 10. By doing that, the student gets a method mark there. Then all I need to do, I need to use this expression here and get the value of x, the age of the daughter, and that is it. The age of the daughter today, that one. So we are looking for the sum of their ages today. So I can do the age of the mother, that is, I can do the one of the son, that is 14, the present one. Okay, we don't know the present, but we can use the past. Like 14 minus 5, yes, 14 minus 5, the age of the daughter 5 years ago times 4, you get the age of the mother, plus 5, 41. So the mother is 41 years, 41 years at the present. Then the sum, 41, the age of the mother, the age of the daughter, add them, you get the answer 1. A very tricky question, but not very difficult for my student to reason out that. Yes, try to practice such questions, my friend. This is question number 7, a question on vectors. Yes, a question on vectors. Remember what you've given before, that the vector OA is 4i plus 4j plus minus 6k. Yes. You're also given that OB is 10i plus 4j plus 12k. So this is all that the student was expected to change into the column form. 4, 4, negative 6. That is the vector OA. Then 10, 4, 12. 10, 4, 12. So by doing that, the student has the first mark. Now, you're given that there is a point D. I think it's a point D, not M. Such that AD to DB is 1:2. So the student was expected to find the coordinates of this point. So over there we use what we call the ratio theorem. The ratio theorem. That states that if I want to find the vector OD, yes, OD, I'll do 2 over the total ratio, 2 over 3 of the opposite vector down here, then plus 1 over the total ratio of this vector here. That is all I've done. 2 over 3 of vector OB plus 1 over 3, yes, of vector OA. And that is it. 2 over 3 of the original vector OB plus a third of vector OA. By opening the brackets, I get these fractions. When I add them up, 24 over 3 is 8, 12 over 3 is 4, then 18 over 3 is 6. And by that, the method is well done, like the ratio theorem there, and the answer is 1. So with that, the question goes with the 3 marks there. A good one there, my student. Review the ratio theorem. Question number 8, you're given a secant WQ and then there is another second YQ and a tangent SQ. So the first part, part A, the student is expected to work out YZ, this one. I mark it X. So what exactly should the student know? That the whole second WQ multiplied by XQ, the part of the second that is produced out there, is equal to the same. That is the whole of this second YQ multiplied by the part of the second that is outside there. Okay, simply as that. In one of the videos I tried to illustrate that well clearly. A WQ, 5 plus 6, 11, times 6, the part that is outside, 66, equals to, the part that is outside is 4, multiplied by YQ, that is X plus 4. Yes, X plus 4. So if I form that expression, yes, the student has a mark. Then going ahead to solve for X, I get another mark. That is 2 mark. Coming to part B of it, QS, the tangent squared, is the same as WQ, the whole second, multiplied by the part that is outside. Again, that one I tried to illustrate. Check on one of my video, angle properties of a circle. So by doing that, this one I know it's 11 times 6, 66. Okay, if I want to find now the QS, I find the square root. I work out the square root, and that is it. So by working out this, by getting out the answer, 1. So 2 mark, 2 mark. Question number 8, done. Question number 9. The student is supposed to solve. You solve that question using quadratic formulae. This is your A. Yes, A is -2. This is the B, the coefficient of X, -9. And C, the constant there is 5. And this is the quadratic formula that you don't need to bother so much with it. It is in the mathematical table. So all you need to do is to substitute. Yes, substitute the values. And by doing that, like in this one, we are talking about minus B. My B is already negative. So negative of negative is positive. Plus, oh yes, now we do the first X. It is plus or minus. So I do with the plus first. So B squared, -9 squared minus 4 times A times C, over 2 times A, as per the formula. By doing that, I get a method 1. So working out this, 81 plus 40, because this is 8 times 5, and it is positive there. So it will be 121. Square root of 121 is 11. 11 plus 9 is 20. 20 over 4, you get the first answer. As simple as that, my student. Then you do with the negative. Over here it was positive, now I can do with the negative. The same story. 9 subtract 11, square root of 121 over that. You get -2 over -4, again you get that. So again 3 free marks there, my student. This is question number 10, a question on further logarithm. Further logarithm. The student is supposed to evaluate and get the value of X in that equation. Now, the catch is somewhere here, because all numbers must have the log to base 2 for uniformity. But before we go to that, we can remind ourselves what we call the laws of logarithm. Law of logarithm. For example, if I have the log of AB, that's A times B, it is always equals to the log of A plus the log of B. So if I'm multiplying the numbers, I add their logarithm. So if I have the log of A over B, it is the same as the log of A subtract the log of B. So when I'm dividing the numbers, I subtract their logarithm. So if I'm having A log B, this can be given as log of B raised to power A. So if I have log to base A of A is always equal to 1. So these are just but some few laws of logarithm. We're going to use these laws and apply them in this equation here. So in this one, I have no problem. It is log to base A of X plus 3X. Over here, I can use the third law here, whereby now this is log to base 2 of 2 raised to power 3. So that's what I've done here. So the power here is it's over there. This one, I apply this law here because this is 2 times 1, and this 1 I will write it in this format. So basically this is 2, that is a 2 times 1, that is log 2 of 2. And that point, that is where exactly the catch was. Now it looks better with a log of 2 than that one is over there. So if I come to the next step here, and if the student was able to express that point, a good mark there. So now I use the first law. 8 times the whole of this is 8, 2 to the power 3. 8 to multiply by this because I'm adding the logarithm here. So you can see the number there. So this is, again, I use the third law. So this 2 will be a power there. So it is 4. 2 times 2, 4. 4 multiplied by the whole of this. Why do I multiply? I'm adding over there. So then that one. So in that case, I can ignore the logarithm. I equate the numbers. I equate the numbers. And that's where the other method mark is. I form that equation, then I solve it. Up to this point, divide by 16, divide by 16. 8 over 16 is simply a half. Another 1 mark for number 10. It is expected to work out the area of the shaded region. Now, you're given that this one and this one forms the radius of a circle. So this is the center. Therefore, we can start working out the area of a triangle. The area of a triangle, we're going to use the sine formula. Area equals to a half AB sine of theta, where AB is any 2 sides, theta is the angle between them. So that's all I've done. A half times 14, yes, times 22, because 14 plus 8, 22 sine of 75, the angle between them. And by working out that, you get 148.75 centimeters squared. That is the area of the triangle. Then we go ahead to work out the area of a sector. Area of a sector is given by theta over 360 pi r squared, where theta is the angle between the sides. Then the radius, of course, the radius you can see, pi and like. So 75 over 360 pi r squared. And again, by working out that, you get that area. So what exactly do I do to get the area of the shaded? Subtract the 2. The area of the triangle, subtract the area of a sector. Yes, this is a sector. By doing that, you get the answer. So that is question number 11. Number 12, you're given that there is a clock. And this clock loses 30 seconds every 1 hour. Every 1 hour, the clock reads 30 seconds less, or loses 30 seconds. The clock was set correctly on Monday at 4:45 hours in the morning. Then the question is asking, what time will the clock read? Okay, the question is asking what time the clock will read on Friday, that is the following Friday. That's a very key word there. The following Friday. That is where the student should be very careful. They are not talking of that week's Friday, the following Friday. That means the Friday of the coming week. I know most of the students will not get that well. But if I say this week or this Friday, that means it is Friday this week. But if I say the following Friday, that means next week's Friday. So between Monday and the next Monday, that is 7 days. Okay, from Monday to Friday, yes, at maybe the very hour 0:45. Yes, that is Tuesday, Wednesday, Thursday, and Friday 4:45. Those are 4 days. From Friday 4:45 to Friday 18:45, that is 18 minus 4. That is 14 hours. So what exactly am I trying to do? I'm trying to get the total number of hours from Monday at this time to the following Friday on or at 18:45. That mathematics there. So I'm talking about 11 days, yes, 11 days times 24 hours in a day plus 14 hours, and we get 278 hours. For every 1 hour, 30 minutes, 30 seconds goes. That means 278 times 30 divided by 60. What exactly am I trying to do? I'm trying to get the same time in minutes. Yes, so the time that this clock will lose within that is 278 hours. And that time, 139 minutes, is equivalent to 2 hours, 19 minutes. And that's where the student scores another mark. Then, of course, what do you need to do? The clock is losing time. So this is the exact hour that it should read. But instead, it will read 2 hours, 19 minutes less, this one. So, and that's what I did. I subtracted, I got the time in 24-hour clock system, then I change, subtract 12, and you get this. And that is it. So the clock will be reading 4:26 p.m. instead of 18:45 p.m. A question that is very, very tricky. That one I have to agree. Very tricky. Number 13, you're given that the cos of x is equal to the sine of 4x plus 30. That is it. You're supposed to get the value of x. Then before you look at what we've done, consider this triangle here, my student. This is a right angled triangle. If this is the angle of interest, this is the adjacent. So this is adjacent, this is the opposite, and this is the hypotenuse. Good. So if this angle is theta, automatically this will be 90 minus theta. Yes, these two angles are complementary. Now let's think about the sine of this angle. That is sine of theta. I can decide to attach A here, B here, and C. So I can say is equal to B over C, opposite over hypotenuse. So that is toa kaso or so ka toa. That sine is opposite over hypotenuse. That is it. What about the cos of the same? Cos of the same will be adjacent over hypotenuse. I'm not interested with the tangent. Now let's think about this angle. That is, I want to work out the sine of 90 minus theta. The sine of this will be A over C. That is now the opposite. If this is the angle, opposite will be down here over hypotenuse. Whatever I'm working out the cos of the same, 90 minus theta, okay, will simply be adjacent B over hypotenuse. So what exactly does this mean? The sine of theta, yes, is equal to the cos of 90 minus theta. That's what it means. And the cos of theta, A over C, is the same as the sine of 90 minus theta. So if these two angles are complementary, if I have to equate them, that means they will add up to 90. Whatever the angle is here, and this one will give me 90. And that's where the student scores the first mark. X plus 4x plus 30 equals to 90. Okay? Then with that, solve for x and get the answer. That is as simple as it is, 2 marks. Number 14, a question on probability. This is just a game of chances. These are a game of chances. And you're told that there's a student here called Jane, that the probability that Jane will pass a chemistry test is 4/7. Therefore, you know the first part A, we are drawing the tree. So I can start right from the beginning. The probability that Jane will pass chemistry is 4/7. So the chances that the same student will fail in chemistry is 3/7. Remember, these two events are mutually exclusive. So they are branches of the tree. If this student passes chemistry, then the chances that she has failed at the same time is not there. So one event occurring excludes the other. So this is the first part of the branch of that tree, a B mark. Now, you're told that if Jane passes chemistry, chances that this student will pass mathematics, two independent events, so you continue. So if this student passes chemistry, chances of passing mathematics is 3 over 5. So chances of failing mathematics even after passing chemistry is 2 over 5. You can see this. So that is the continuation of that branch. Otherwise, they're saying, in case this student fails chemistry, chances of this student passing mathematics is 0.3. That is 3 over 10. So chances of the student failing in mathematics as well, it is 7 over 10. The remaining to make 10 here. So for these other branches there, the student scores that. So maybe drawing a tree, for most students, it's a bit challenging. But if you practice, you'll finally get it. Now, I can now use my this tree, the probability tree or the tree diagram here, and work out the probability that at least Jane passes an exam, a test, one test. So the probability that Jane passes at least a test. So where is that case? So for example, in the first case, the chances or the possibility Jane has passed in mathematics and has passed in chemistry, all chemistry starts. Then in this one, the student can still pass in chemistry but fails in mathematics. Okay, you can see that. Over here, the student can fail in chemistry but pass in mathematics. So, but in the last case, fail chemistry, fail mathematics. So this one is not there. But I can consider this. 4 over 7 times 3 over 5 plus 4 over 7 times 2 over 5, it's here. Then 3 over 7 times 3 over 10. I put them together, I get an answer there. And of course, the working pair 1. So 2 marks again for the tree. That is probability, my student. Do not fear probability. It's not difficult to handle. Number 15, you're given these two lines. Line AB, and then you're given another XY that is perpendicular to AB at a point Y there. And of course, this part AY, YB, they are equal. So that means Y is the midpoint. Good. What is the question? We find the question of this line XY. So first of all, let's find the midpoint. The X coordinate 4 plus minus 2. Divide by 2. The Y coordinate 7 plus minus 1. Divide by 2. And by doing that, I get the midpoint, 1, 3. You can be able to follow what I've done there. Now, I can go ahead to work out the gradient of this AB. The change in Y over change in X. And that is what I've done. Using the concept that the product of the gradients of two perpendicular lines equals to -1, I work out the gradient of this line. That is what I'm calling M2. And by working out the gradient of M2, I get another mark. So then I have a point, this one, 1, 3. I have the gradient, like that. I've worked out this to be -3 over 4. And I have a point XY. That is enough for me to work out the equation. The change in Y, Y minus 3 over X minus 1 equals to the gradient. I only need to put it in a better format. That is the gradient intercept form. And by working out that, I get a mark. Just follow what exactly I've done. This is number 15. Number 16, you're given the measurement of a rectangle, 12.0 centimeters by 8.0 centimeters. The question is, you work out the percentage error in the calculation of the perimeter. All I've done is to find the actual perimeter. Yes, the actual perimeter is there. The maximum possible perimeter. Remember, the maximum possible length will be 12.05. The minimum possible is 11.95. On this one, the maximum is 8.05. The minimum is 7.95. Okay. So with that, I'm able to work out the maximum possible perimeter. The maximum length plus the maximum width times 2. And by working any of the two, you get a mark. You can decide to do the minimum perimeter as well, though maybe in this case it will not be necessary to do both, but you can do both. Then get the error. The maximum possible perimeter minus subtract the actual perimeter. Or rather, you can do the actual perimeter minus the minimum. The answer will be the same. So by that you get a method mark. Then the percentage, you get the error, 0.2 over 40, the actual, times 100, you get that. And that's how you get the number, the 3 marks for number 16. That is the end of section 1.